Hello, this is Mrs. Wong here. We're looking at question 5 of the 2E revision worksheet for term 3WA. The figure below shows two squares ABCD and PQRS overlapping each other. Given that AB is 13, AP is 10, and CQ is 9 cm, part A requires us to find the length of PQ. For this part, we do have to recognize that AD and DC are both 13 cm as well, as they are sides of a square. Finding the length of PD and DQ would help us use Pythagoras theorem on triangle PDQ to find the length of PQ. So for part A, an important aspect is that I recognize my right angle triangle PDQ so that I can actually find the length of PQ after I've found the length of PD and DQ. Part B wants us to find the shortest distance H from D to PQ. First, we have to identify what the question meant by the shortest distance H from point D to line PQ. If we were to look at the diagram, I want the shortest distance of the point D to the line PQ. It would give me something like this, perpendicular line from D to PQ. So they want to find this shortest distance H. To find this, we have to see what information we have currently. We do know all three sides of the length of triangle PDQ. We do not know any of the angles, though we can find those. So what we can try and use, one of the ways to find the length of H is to actually use the area of triangle PDQ, and we will change the base and the height, but the area of this triangle remains the same. So one way to find the area of triangle PDQ is to take half times DQ as the base times PD as the height. That would also be the same as if I were to take PQ as the base, so half times PQ times H, the perpendicular height. The two areas can then be equated to each other to help me find the value of H. So I write it clearly. Half times the length of PQ times H equals to half times the length of DQ times PD to help me find the length of H. You can actually draw a diagram to help you. Okay, so H is actually over here. And I know the length of the three sides of the triangle. Part C wants us to find the angle of PQD. So we have our triangle PDQ, and the angle that we are interested is here. You can label that as theta, or you can just label it as angle PQD. So you have all three sides of the triangle. It's up to you to use your trigonometry ratio to find the angle. So one possible way is for me to use tangent of the angle, and I equate it to opposite over adjacent. You can also choose to use the trigonometric ratio sine of the angle, but I have to now take the opposite over hypotenuse, or you can also use the cosine of the angle, where you have to take adjacent over hypotenuse. So all of these three trigonometric ratios should give you the same angle, PQD, as 36.9 degrees corrected to 1 dp.